and welcome to another video. Today I will try to learn C, and I have like no knowledge about C at all, but I do, however, have, let's say, learned about programming in TypeScript and JavaScript, which is very, let's say, not really difficult because you don't have to worry about the tools and such. And there are a lot of tutorials out there, which is very helpful. Okay, anyway, and since C is a low level language and we have to manage our own memory, and I want to learn about memory management. So, yeah, let's see here. We have a very cool website which is learnc.org. I think this is community driven. I'm not sure though. And since I don't have a compiler, I haven't found a good compiler. So if you do have one, then please comment down below. I would appreciate it very much. Or rather, I will appreciate it. Yeah. Okay. Let's see. Introduction. Okay. General purpose. Yeah, it's what Python is made of, and the conventions of C is what inspired other programming languages as well. Although C can be considered as hard to learn, C is in fact a very simple language with very powerful capabilities. We'll see about that. C is a very common language, and it is the language of many applications such as Windows, the Python interpreter, Git, and many more. So Git is very useful for version control flow. And I might make a video about it in the future after I learn more about it. But let's proceed. It's a compiled language, so pretty much it will go through your code and then turn that code into a binary code or an executable. In this case, it is a machine code wherein the machine can directly read it. Okay, which means that in order to run it, we need a compiler. For example, GCs or Visual Studio must take the code that we wrote, process it, there we go, and then create an executable file. Mhm. This file can then be executed and will do what we intended for the program to do. All right. So this is why we are using an online, uh, yeah, here, like, you can do exercises. It's an online compiler. Wow. Oh, it's very slow though. Yeah, there we go. Very nice. Okay, let's see. So we have variables. Okay. C has several types of variables, but there are a few basic types. Okay. Integers, whole numbers which can be either positive or negative. Hmm. Defined using char means short, long, or long, long. Oh, oh, okay. Unsigned integers, whole numbers which can only be positive. Defined using unsigned char, unsigned int, and okay, unsigned the ones above. Then we have floating point numbers, real numbers, or I guess decimals because it's mentioned here fractions. Okay. And since, JavaScript also have them and they're called floating point numbers. Or when you want to convert in a string that contains number representation, for example, quote unquote 0.5, something like that, you pass it inside the native, not really native, but like an inbuilt method in JavaScript named parseFloat. So yeah, it's a floating point number, decimals. Okay, it can be defined using floats and double. Mhm. Structures. I think structures, since I've been studying Rust as well, it's like classes in JavaScript. So like pretty much objects with methods and such. But we'll see. Since based on what I've read, like the general definitions of C, is that it is procedural, wherein everything is just in functions. There's no object-oriented programming involved. Let's see. The different types of variables define their bound. Mhm. A char can range only from negative 128 to 127, whereas a long can range from a very long, a large number rather. Long and other numeric data types may have another range on different computers. For example, okay, very large number again on 64-bit computers. So I guess it depends on how capable your computer is, like the amount of bits. Okay. Note that C does not have a Boolean type. Okay. Usually it is defined using the following notation. C uses arrays of characters to define strings and will be explained in the string section. Oh, so false is 0, true is 1. There's no Boolean like false and true. So you can use 0 and 1 instead? Hmm, probably. But yeah, let's just proceed. We'll find out about that later on. Let's see here. For numbers, we will usually use the type int. On most computers today, it is a 32-bit number, okay? Which means the number can range from a very large number, from negative to positive. To define the variables foo and bar, we need to use the following syntax, int foo. So this is almost the same as TypeScript, I guess. The difference is that instead of using keywords such as const, let, and var to declare the variables, we just not really prefix, but place the type of the variable right before the name of whatever variable it is. Okay, so if the type of this is an integer, or if the type of the variable foo is an integer, then we place that behind foo with a space, of course. Interesting. Okay. The variable foo can be used, but since we did not initialize it, we don't know what's in it. The variable bar contains the number 1. Alright. Now we can do some math. Assuming A, B, C, D, and E are variables, we can simply use plus, minus, and multiplication operators in the following notation and assign a new value to A. Let's see. Oh, interesting. Just like in, well, again, TypeScript, you can do something like this, where you don't really need to use the keyword. For example, a let var in const. You can just use a comma, and whatever comes next, for example, a new variable, will the language will automatically infer to you that, oh, okay, if for example in JavaScript or TypeScript, we declare that the first one is a const, then the next one after the comma will be a const as well, or a constant variable. But in this case, it's for types. So if the first variable here before the comma, its declared type is int, then the next ones after the comma would be an int. Okay. What I'm curious about is, are semicolons mandatory? Because in JavaScript, it's really not. It's just a good practice. But let's see what's happening here. Int A equals 0, B until E, for A equals, so we minus 1 to C, 1 minus 2, or the first operation actually is D times E, so 3 times 4 is 12. And then this one, B minus C, is 1 minus 2, negative 1. So negative 1 plus 12 is 11. Okay. Start exercise. What's this? Oh, all right. So here printf is the console log version of C, I guess. And the difference between this and the console log in JavaScript, I guess, is that there are format specifiers. Since I've used Rust, I know somewhat a little bit about them. It's like a dynamic variable when you declare, or rather, it's like when you use template literals. So what are template literals in JavaScript? Well, they are pretty much like this. Can I edit this actually? Hello? Oh, there we go. Okay. This back to backtick, so it's pretty much a quotation, but in backticks, excuse me. And what we can do here is have a dollar sign and brackets, and whatever is inside will be considered as, let's say, a variable, okay? Something dynamic. In this case, if we have a variable above named, let's say, dog above here, then this value, the value of this will be equals to whatever the value of the variable dog is, okay? What's this called again? I completely forgot. No, it's not string concatenation. But yeah, it's like a template literal, but in here, it's a format specifier, they call it. So I guess for integers, it's percent sign %d, okay? And then the arguments. So the first argument for printf is the text message that you want to be displayed. Meanwhile, the other arguments would be what the value that you want to place inside the format specifiers. So you can consider this as a variable or something dynamic. So the value of this will be equals to whatever you pass here. Okay. Just like here, for instance, below. We're trying to print the value, the value of the variable sum, which is up here and down here. And we declare that with %f. So I guess that stands for float, pretty much. How about D though? What does it stand for? I'm not sure. Oh well, let's proceed. Let's see. Oh, we are already at the race. Interesting. Can we go back? Hmm. We have a double and a float, so they're pretty much the same. Eh. Float sum. So this is automatically inferred as no value or as zero. Uh, but why do the decimals have this much in them? Until 6, 1, 2, 3, 4, 5, 6. Yeah. So what if we say equals 0.24? Let's see. Okay. There's no statement here that says that, huh? Hmm. So maybe we can do something like this. No? Oh, well, let's just proceed to erase. Okay. So arrays are special variables which can hold more than one value under the same variable name. So are these the real arrays wherein like we cannot change nor no, yeah, we can change it. No. We cannot change it at all, I think. Yeah, it's a fixed value of, well, set of values rather. But we can, however, I think, is change the values inside. I should dig more about that. Okay, anyway. Organized with an index, yeah, just like JavaScript. Arrays are defined using a very straightforward syntax. Okay. Accessing a number from the array is done using the same syntax. Notice that arrays in C are zero-based. Uh-huh. So always -1 starts at 0. Is there a programming language that does not start with 0? I'm not sure. Let's see. Okay, so this is pretty much a bracket notation. You can call it that. Which pretty much means is that you're accessing the value of the index of whatever you pass in here. So for example here, the sixth index of the numbers, of the variable numbers array, or it can be an object in JavaScript, but in this case, it's an array, okay? So the sixth index would be 0, 1, 2, 3, 4, 5, 6 here, 17, okay? Hmm. Now let's see if we can actually try to, what's this? Define the grades variable here. Okay. Int grades. How many do we have? 0, 2. Find the missing rate so that the average will sum to 85. Oh, so this is actually an exercise. What have I been doing? Okay, let's try to do this actually. Uh, so we have 3. The length of the array is 3 because we have the 0th index and the second index, right? And the only time or the only items that we're accessing is the 3 items. Excuse me. So the missing item would be, so we want the sum. Is it really a sum? Shouldn't it be quotient? Because we're dividing by 3. Oh, I'm being a smarty pants. Let's just try to solve for this. Grades 1 is equals to, let's add 80, 90, that would be 170, right? Yeah. So we need 85, maybe 85. So 165, that would be 255 if I'm not mistaken. 60, 30, uh-huh. Yeah, I think it's 255 because 9 plus 6 is 15, right? Yeah, it's 255. Divided by 3 is 25 divided by 3 is 8, 5. Oh, wow, I'm correct. That's cool. Okay. Oh, so really, you need to do the exercise. Oh, this is a very tricky question. Like, I guess they don't want you to really think much about it. Okay, let's see. Multi-dimensional arrays. So pretty much an array inside an array or an object inside an object, right? Yeah, let's see. In the previous tutorials on arrays, we covered, well, arrays, how they work. The arrays we looked at were all one-dimensional, but C can create and use multi-dimensional arrays. Excuse me. Here's the general form of a multi-dimensional array declaration. Okay. For example, here's a basic one for you to look at. So we have, so this array has, well, one array or one length or one item. And that item is an array based on what we see here. And this array has 2 items or 2 arrays because here again we have this. Okay. Or maybe this one. So we can use brackets. Interesting. So it's not just on curly braces rather, not brackets. Okay. Let's see. The simplest form of multi-dimensional array is the two-dimensional array. A two-dimensional array is pretty much a list of one-dimensional arrays. Well, yeah, pretty much. It's all verbose. You can just call it an array inside an array. Okay. To declare a two-dimensional integer array of size x and y, you would write something like this. Okay. Where type can be any C data type. Okay. An array name will be a valid C identifier or variable. A two-dimensional array can be considered as a table, which will have x, number of rows, and y, number of columns. All right. A two-dimensional array A, which contains 3 rows and 4 columns, can be shown and thought about like this. A00 here, 00, one item. Okay. Oh, so this is already an item. Okay, so one item, one item. So this is the index. Oh, this is pretty confusing because it's like they're trying to declare the array, but in here they're accessing the item. All right. right? Yeah. So one, two, three, four, five. Yeah. Let's see. In this sense, every element in the array A is identified by an element name in the form, okay, where A is the name of the array and I and J are the indices that uniquely identify or show each element in A. So yeah, these are indices. So it's pretty confusing because there's no like, okay, these are indices at the top here. But yeah, makes sense. So we did something like this. Yeah, this is not readable, but it's good to know that you can do something like this. All right. But you need a y value, okay? Whatever you're using, you have in the dimensions. Keep that in mind. Initializing two-dimensional arrays. Multi-dimensional arrays may be used by specifying bracketed values for each row. Below is an array with 3 rows and each row has 4 columns. To make it easier, you can forget the 3 and keep it blank. It will still work. So basically, you will forget about this here. And it will automatically infer for you of whatever's inside or how many arrays, or in this case lists there are. But it's interesting that you can use curly braces here. Mm. Okay. The inside braces, which indicates the wanted row, are optional. The following initialization is the same to the previous example. Oh, so it's the same. However, I find this difficult to read, especially if I don't know that, you know, this works like this up here. Hmm. All right. So I guess the compiler will automatically distribute the elements for you, I think. Yeah. Okay, let's proceed. Accessing two-dimensional array elements. An example in a two-dimensional array is accessed by using the subscripts. Excuse me. So pretty much the index of the column and the row. All right. The above statement will take the fourth element from the third row of the array. So pretty much from 0 to 3, the second index would be the third item. In this case, the third list. And the same can be said for the second notation. That would be for inside this list, the third list, we want to take the fourth item in that list from 0th index to the third index. Okay, let's see. Let's start an exercise. Declare the 2D array grades here. See the instructions. Let us try to find out the average marks of a group of 5 students for 2 subjects, mathematics and physics. To do this, we use a two-dimensional array called grades. All right. The marks corresponding to mathematics would be stored in the first row. Okay. Whereas those corresponding to physics would be stored in the second row. So math and physics. Complete the following steps so that you can execute this program. Okay, let's see. What do we need to do? Declare grades as a two-dimensional array of integers. Complete the for loops by specifying their terminating condition. So when will we break out of the loop? Okay, let's see. And then we want to compute the average marks obtained in each subject. All right. Is there a way to like expand this? I'm not really satisfied with how small this is. Huh. Okay. Let's just make do with this. Let's see. average into I into j. Okay, so these are the grades. Complete the for loop with appropriate terminating conditions. Compute the average marks for subject I. The average marks obtained in subject is So I'm guessing this is how they cut off the decimal places, because earlier we had like 6 decimal places for floating points. And I guess when you do this, you will only get 2 or whatever you specified, I guess. Okay. Let's see, how do we do this? So we have a 2D array of grades. So int grades. How long will this list be? So the first, 2 items only. And 5 grades, right? 1, 2, 3, 4. Yeah. Would be 2 items and 5 items per list, or 2 lists and then 5 grades per list. And those lists are respectively mathematics and physics, right? Yeah. Okay. Let's see. What do we need to do in the for loop? I equals 0 as long as I. Oh. So they basically just removed. Okay. So can we access the length of the grades? Grades dot length. Is that possible? Let's try it out. Grades I dot length. So to access the length of an array in JavaScript, you can just, or a list, you can just do the property length or access the property length with dot notation. Will this work? Probably not. Yeah, there's a problem here. Because for member length in range, which is some down class type int. Oh, okay. So I guess we can just make it hard-coded instead. In this case, we have 2 and 5. Let's see. Yeah, that works, but we have a problem, I think. Oh, it should be average. And here we are just adding them, right? Yeah, so after the loop inside the J, so that would be after looping through all of the grades per subject or per iteration of the I, of the variable I, in this case per item. Since per item that we are iterating over, we also iterate over their items. So let me rephrase myself because I just made a redundancy there. It should be somewhat different so it's understandable. So let's see. On the first for loop, we are iterating over the lists that is inside of the variable grades in here. Okay, so we have a list inside a list, a multi-dimensional array. And a list is pretty much an array as well. Okay, I'm not sure in C though, but yeah. And inside those lists, we have 5 items. So that is why in here, per list or per array, we are doing a for loop for that, wherein we are trying to access the items of the list that we're currently at. So that would be the letter I here. Okay, so for example, if the value of I here, the variable I in the loop, is equals to 0, since on the first iteration it's equals to 0. So this is how loops work, if you are unfamiliar with it, since I was as well. On the first one, before the semicolon, so we have 3 statements, okay? The first statement is the initialization or the declaration of the value of the variable that we want to watch out for to terminate this loop. Because a loop needs to be terminated at some point. So in the for loop, we have this format, okay? We initialize the variable that we will change for termination. And at the second would be the condition whether to run this loop or not. So in here, we get a reference to the value of the variable I. Is it less than to 2? If that is so, then we will run the code below, which is the loop pretty much. Okay. And after running the code inside the loop, which is inside here, in here, the one I'm highlighting, then this is the post operation. What do we want to do next before we proceed to the next iteration? Excuse me. So in this case, we want to increment I by 1. And I'm not sure if this is true, this I have not really dug deep about it, is that we can do something like this to make a teeny tiny bit of optimization to our for loops. And what this does is pretty much is because post increment or pre-increment is pretty much an operation wherein this operation returns a value if you assign it to a variable, wherein pre-increment returns the incremented value while post increment returns the value before the number was incremented. Okay, all right. So anyway, where was I? So here, after we add the average, which we declare here, okay, then we want to divide it based on the length of the list or the items or the grades, because that's how we get averages or average. So we can just say average over is equals to rather average over 5. There we go. That should do it. There we go. Very nice. Good job. Okay, let's move on to one more lesson, I guess, and then that will be it for today. Let's see, we have conditions. I think this should be easier, I hope. Let's see. Decision making. In life, we all have to make decisions. Okay. In order to make a decision, we weigh out. In order to make a decision, we weigh out our options, and so do our programs. Here is the general form of the decision-making structures found in C. Okay. An if statement. Execute different code according to the result. To evaluate whether two variables are equal, the equal operator is used, just like in the first example. Inequality operators can also be used to evaluate expressions. We can use the else keyword to execute code when our expression evaluates to false. Okay. Sometimes we will have more than two outcomes to choose from. In these cases, we can chain multiple if-else statements together. Okay, very familiar. Yeah, but there are other techniques here to make this more readable, but this is pretty good. Yeah, so this is called ampersand. So one and ampersand. And this is an AND operator. So this combines the two. If need if neither of this is evaluated to false, then we will not run this code. Or rather, the only way that we will run this code below is that if both of these statements are true. Meanwhile, in here, this is a short circuit, they call it, or an OR operator. We will run this code below if either of these statements are true. So in this case, if this is true, then we don't care about the, excuse me. If the first statement is true, then we do not care about the second statement. Okay, this will just instantly run. Meanwhile, if this statement evaluates to false, then we will check if this is true, or rather the program will check if the second statement is true or false. If it is true and the first statement is false, then we will still run the code below or inside the if statement. Okay. So the not operator, so pretty much an inequality operator. If this value is not equal to 10, that means this statement is true. Okay. Let's see here. Write your code here. Guess number. What do you mean? In this exercise, you must construct an if statement inside the guess number function statement that checks if the number guess is equals to 555. If that is the case, the function must print out using, correct, you guessed it. Your guess is too low. If guess is greater than 555, the function must print out using printf your guess is too high. Okay, that should be pretty easy. You can just say if guess is equals to 555. Okay, there's no autocomplete. We can just return. So this is one of the tactics or techniques for, uh, to avoid having a very long if else, although that's pretty much recommended. But let's see. Return, correct? You guessed it. Since this is the main, what can we call this? The main breakpoint, I guess. Like the main thing that we want to look for rather. There we go. And in here, we can just say that return, yes. So this is a ternary expression, although we are talking about if-else statements. But yeah, we'll learn about ternary expressions as well. If it exists in C. So we'll see. Oh, right. Okay, anyway. Return guess. So is guess less than 555? All right, we can't use. Oh, never mind, never mind. We can use the ternary. Okay. Is guess less than 555? Then we, or rather this value that will be returned would be equals to your guess is too low. Else, so pretty much in a ternary expression, we do the statement that we want to evaluate first. Is this true or not? If if it is, then we will run the function right beside the question mark right here. Else, if it is not true, then we run the function right beside or right after the colon. Okay, and just return. Or the value of the return would be oh wait, it should be a printf actually. Okay. So we can do something like int to be, or rather char, to be printed like so. And then we can just do something like this, to be printed equals to. So in this case, we can't really use ternary expression. I should really read the, what do you call this? The instructions here. But anyway, this should be pretty good. So anyway, if it's not equal to 555, then okay, one of the techniques again is instead of using if else, although again it's more recommended to use it that way, but sometimes it really just gets cluttered up. So you can just do something like this. Like that. Okay. And same for greater than. There we go. Okay, then to be printed equals to your guess is too low. Like that. Okay. Again, your guess is too high. Then we can just print f percent sign C. I think it's C. And then the line break to be printed. Okay, let's try it out. And char to char. What do you mean? Oh, okay. So I guess I got the types wrong. What type should this be? Const char to char. You guessed it. Hmm. Maybe this should be an int. I'm not sure. Should it be char? I mean, because it is, I think it's because we are changing the value. So have, how can we tell the compiler that this will change? From const char to int. Oh no, I made it to be char now. So do I need to do it like this? Const char star. Or do I need to have a star here? Because this, I think this is the like the borrow, no, not borrow checker. Borrow checker is in Rust. Memory allocation. There we go. Let's see. Oh, what is this? Slash API. Okay. Um, let's say the solution. Oh no no no! Why did you? Oh, is there an undo button? I mean, I guess this works too. So we can just decouple this instead of the way I did it. There we go. Oh, I'm not sure about that conversion of char to. Well, we can do this way, or we can do it this way. Definitely. Was what? But what was that earlier? Hmm. Okay. We will probably know more about that when we proceed here. But let's see if this works. Oh, there we go. Nice. Why don't we get the correct you guessed it. Oh, of course. There we go. That should be it. Hooray! Okay, so we will know about what we were talking about, or what I was talking about tomorrow, or maybe right here, right now. Here, there you go. Okay. Uh, yeah, I should stop here for now. I'm quite enjoying learning C. It's a breeze, really, because well, I've been like programming in TypeScript for a while. But yeah, I definitely don't know a lot, especially like this guy here and memory allocation and yada yada. That's it for today, and thank you for watching. I hope you learned something together with me, because I learned something definitely. And good luck on your development journey. Happy learning.